In question 4 part A, we're introduced to a cubic function x cubed plus kx squared plus 15x plus 8. We're asked to prove that k is equal to minus 9, and the only piece of information that we're given really is that the derivative, that f dash of 3 is equal to minus 12. That's the only piece of information we have. You should recognize that if they've told you that when they sub in x equals 3 into the derivative, obviously the first thing I need to do is guess the actual derivative of the function. So if f of x is equal to this, your very first step should have been to get f dash x. The derivative of x cubed is 3x squared. The only issue I see people having here is maybe with the kx squared. Just treat the k as if it's a constant, like a 2 or a 5 or a 7. If, let's say that was 7x squared, what you would do is you would bring the 2 in front, you'd multiply the 2 by the 7, and it would become x to the power 1. That's exactly what we do here. You multiply 2 by k and you get 2k, and it becomes x to the power 1. So the derivative of kx squared is 2kx. And the derivative of 15x is 15, and the 8, it's just gone. Once you have the derivative, you should realize that you need to sub in x equals 3. If I sub x equals 3 into the derivative, I know it's equal to minus 12, because it tells me that in the question. F dash of 3 is equal to minus 12. So simply, instead of an x, I subbed in a 3, and I let the whole thing equal to minus 12. And from there, like, you can ignore the left of this, from there it's really straightforward. You just simplify it down and you end up with k equals minus 9, and that'll get you the marks for part A here. Now in part B, I'm told that the line g of x, which I can see in the diagram, goes through the maximum point of this function and goes through the minimum point of this function. And I'm asked to get the equation of g of x. In order to get the equation of a line, I need to use that formula y minus y1 equals m times x minus x1. But in order to get the equation of this line, what I'm first going to need to do is to find 2 points on the line. The 2 points on the line g of x that I'm going to try and find are the maximum and minimum point of this function. So if I can find the maximum and the minimum point of this function, I will then have 2 points, and I'll be able to say both of these points are on the line g of x. And then it's just going to be coordinate geometry. It'll be easy enough. It's like junior cert coordinate geometry. We'll be able to get the equation of g of x. But before we do that, I first need to get the maximum and minimum point of this function. In order to get the max or min point of a function, the first thing you always do is you get your first derivative. The derivative of this function is 3x squared minus 18x plus 15. And that represents the slope of the function. In order to identify a turning point, I have to let the slope equal to 0. At a turning point, the slope is equal to 0. And I'm just going to factorize and solve this quadratic to find the x values of the turning points. So here I can divide everything by 3. My function is actually x squared minus 6x plus 5 equals 0. And if I factorize this, I'm going to get x minus 5 multiplied by x minus 1 equals 0. So what I can do now is just let each factor equal to 0 and isolate my x. I'll get x equals 5 and x equals 1. So I know that the x values of the turning points are when x equals 5 and when x equals 1. But to find the actual points, I need to find the corresponding y values. So I need to go back to the original function. I want to know if I sub in x equals 5, what's the corresponding y value? Or if I sub in x equals 1, what's the corresponding y value? So I'm going to sub in my x values into this function to get the y coordinates now. So I subbed in, everywhere there's an x, I subbed in a 5, and the corresponding y value worked out as minus 17. So I can say that one of the turning points is at 5 minus 17. I then got the other x value, I subbed in x equals 1, and the corresponding y value was 15. So the second turning point is at 115. And I know that the line I'm looking for, g of x, goes through each of these points. If I know 2 points on a line, it's very straightforward to get the equation of that line. So I know 2 points on the line g of x are 5 minus 17 and 115. So I went to my maths tables and I got the formula for the slope of a line. It's y2 minus y1 over x2 minus x1. My slope works out as minus 8. I then want to use the formula for the equation of a line. My x1, y1 is 5 minus 17 and my slope is minus 8. So you simply sub in, it's straightforward enough. And when I decided to format it with g of x. Remember that when you're writing g of x equals or f of x equals, it represents the y. So I isolated my y. The equation of this line would be y equals minus 8x plus 23. But then you rewrite your y as g of x, because that's the terminology they used in the question. So I can say that g of x is equal to minus 8x plus 23. And that is the equation of the line that goes through the maximum and the minimum point of my function. In the final part of question 4, we're asked to prove that the point of inflection of f of x lies on the line g of x. You should remember that at a point of inflection, the second derivative is equal to 0. So I'd already worked out the first derivative from part B. Now I get my second derivative and it works out as 6x minus 18. In order to find the coordinates of the point of inflection, you let your second derivative equal to 0 and you end up with x equals 3. And now, so I know that when x is equal to 3, I have a point of inflection. But you need to find the corresponding y value. So you go back to the original function and you sub in x equals 3. When I subbed in x equals 3 into the original function, the corresponding y value works out as minus 1. So what I've done here is I've worked out that the point of inflection exists at the coordinates 3 minus 1. And now I need to just sub this point into the line g of x from part B, and hopefully this point lies on the line g of x. I had worked out in part B that g of x is equal to minus 8x plus 23. And I worked out just a moment ago that the point of inflection is 3 minus 1. So 3 is my x coordinate, minus 1 is my y coordinate. Instead of g of x, I subbed in my y. Instead of x, I subbed in my 3. And when I simplify it down, I get minus 1 equals minus 1. So obviously this point does lie on the line g of x. And that'll get me the full marks for part C.